Previously, we talked about GPT models for generating texts. Let's now talk about the BERT model that can be used for classification. So previously we mentioned that the GPT model is essentially the decoder part of the transformer architecture. And in the GPT model, what we did is for the pre-training, we trained it to predict the next word in an unlabeled dataset. So BERT takes a slightly different approach. Instead of predicting the next word, it will predict masked out or hidden words in an input sentence. And because there is no direction to it, it's also sometimes called a bidirectional or non-directional model. And in addition to this masked word prediction task, it's also pre-trained to predict the sentence order. So if I give it 2 sentences from a document, it can predict the right order of these sentences if I shuffle the sentences. But of course, the general structure also applies here, where we first pre-train the model and then fine-tune the model to the target task. Note that we previously said that GPT is essentially the decoder part of the transformer. BERT is now the encoder part of the transformer. So how does this pre-training task in BERT look like, where we predict the input sentence given randomly masked words? So in particular, we take an input sentence and then we randomly mask 15% of the input words. So for example, if we have this input sentence, the curious kitten deftly climbed the bookshelf, we might randomly select the word climbed to mask it from the transformer model. So we randomly pick 15% of the words and then assign a token to it. And 80% of the time for these marked words, we replace them with a mask token. And 10% of the time, we replace it with a random token. And 10% of the time, we don't do anything. So sometimes we have the complete input sentences as well. And this way, the model learns that it sometimes doesn't have to predict something at all, which is important when we apply this model during inference. Now, I mentioned before that there is a second pre-training task, and that is predicting the sentence order. So for example, imagine we have 2 sentences, sentence A and sentence B. They are separated by a separator token, and then we randomly shuffle these sentences, and the network has then to predict the right order of the sentences, like which sentence comes first in the document. And remember that transformers are many-to-many architectures where we have one output token for each input token. So in this case, in order to get a classification output, what we do is we prepend a classification token here at the beginning, which at the output then will have the classification in terms of, in this case, which sentence comes first. So if our classification task is then to predict the next sentence in a document, we can assign the label isNext, and the classification token could be then equal to true or false given the answer. So here is an example where I took 2 sentences from a document, and at the top the sentences are in the correct order, and at the bottom the sentences are in the wrong order. So in the top case, we want the model to predict true for the classification token, and at the bottom we want the model to predict false for the classification token. Now, similar to before when we talked about GPT, there are 2 ways we can fine-tune the model. There's the feature-based approach and the fine-tuning approach. Similar to before, for the feature-based approach, we keep the model frozen and we just work with the output embedding, which serve as input features to a classifier. And then for the fine-tuning approach, it's also similar to before, where we then add a few more layers to the network and then either fine-tune the new layers only or the complete language model. Okay, so this was a brief tour of the BERT model, and in the next videos we will take a look at how we can actually concretely fine-tune the BERT model using PyTorch.